This is looking at our last part of our geometry basics video. We're looking at slope, distance, and midpoint. Now, slope is a concept that was covered in Algebra 1. So see if you can find the slope between these 2 points using the slope formula. Now, just in case we do not remember the slope formula, our slope formula is y2 minus y1 all over x2 minus x1. So change in y's over your change in x. If you feel comfortable with this formula, go ahead and complete 1 and 2, and then check your answer after I have. If you need the quick algebra review over this formula, I am going to work through it on number 1 with you. So first things first, I'm going to label my points. We're going to have an x1 and a y1, and an x2 and a y2. Please make sure you keep each point having an x and a y. So we have x1, y1, x2, y2. Now that we have them labeled, we are going to substitute into our formula and simplify. So we have y2 minus y1. So we're going to have 10 minus 7 all over x2 minus x1, 4 minus a negative 3. Now, 4 minus a negative 3 is going to become a positive, because when you minus a negative, that is going to turn into a positive value. 10 minus 7 gives us 3. 4 plus 3 gives us 7. We are going to keep it as a fraction. Please do not turn it into a decimal. Keep it as a fraction. So our slope is 3 over 7. If you needed that quick algebra review, try number 2 on your own. Pause it real quick. Now to double check that we did these correctly, x1, y1, x2, y2, y2 minus y1, we're going to have negative 2 minus a negative 5. Again, minus a negative is going to become a positive. Let me change that color. And then in our denominator, we're going to have negative 6 minus 1. Negative 2 plus 5 gives us 3. And negative 6 minus 1 is going to give us a negative 7. Now, with this one being a negative 3 over 7 instead of a positive like our previous problem, we can put that negative on the top, on the bottom, or out to the front. Either way is going to be fine. Now, looking at our other 2 formulas, we're looking at midpoint and distance. So before I just give you the midpoint formula, I want you to do some thinking on maybe how we would find this. So it says LaTanya is decorating her living room and draws the following floor plan to help look at placement. LaTanya wants to hang a picture at the center of the back wall. How would you find the point at the center between A and B? So here's point A, here's point B. Before I talk you through it, think through how would you find that center point between A and B, and go ahead and jot down what point that would be. Now, hopefully you were thinking through, if we are looking for the center, we are looking halfway between A and B. So there should be equal space on the left and equal space on the right. So what I'm going to do is I'm going to find the distance between A and B. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 spaces between A and B. If we want the center, we want half of it on one side, half on the other. So I'm going to take 11, divide that by 2. That gives me about 5.5. So I'm going to go 5.5 blocks from A. 1, 2, 3, 4, 5.5. This is that middle point right there. And we could estimate where that would be. That's about at 6.5, 10 on our picture. But now let's look at maybe a little bit more complex. It says LaTanya wants to place a lamp halfway between the chairs at point C and point D. So how would we find that point between C and D? Take a second, think through it. Now, when we looked at A to B, finding the midpoint, we were just going in a horizontal direction. From C to D, this is more of a diagonal direction, which means we need to find that halfway point vertically and horizontally. So if we go straight down from C to D, we notice that there are 4 blocks going down and 2 blocks going across. So if we do the halfway point of both 4 and 2, that would be this line and this line. Halfway between 4 is 2 at the top, 2 at the bottom for our C. And then going across at the bottom, halfway with 2, is 1 on both the left and the right. This would make our midway point right here at point 10, 7. Now I'm going to write out the points for C and D. D is 11, 5, and C was 9, 9. What do we notice about these points? Between our 9 and our 11, 10 is halfway in between them. And between our 9 and our 5, 7 is halfway in between those. So to find the midway point, an equation you can follow with that is you can graph it and find the middle point horizontally and vertically. Now, a way to do that algebraically is to take the x values and divide by 2, add them together, divide by 2. 9 plus 11 divided by 2. 9 plus 11 is 10. Not 10. 9 plus 11 is 20, excuse me. 20 divided by 2 gives us 10. Comma, you'll do the same thing. Y1 plus y2 divide by 2. As an example up here again. 9 plus 5 divided by 2 gives us 14 divided by 2, which does equal 7. Now this is a point. To find a point, you cannot plug those both into your calculator at once. You have to find your x values separate from your y values. So if we look at example number 10, finding the midpoint of A, B, you're going to set this up as 2 different problems. Add your x values together. -3 plus 4 divide by 2. -3 plus 4 gives us 1. 1 divided by 2 is 1/2. So our x value is 1/2. And then we're going to have our y value. Add your y values. 2 plus -2, all divided by 2. 2 plus -2 gives us 0. 0 over 2 gives us 0. So your final point is the x value and the y value together. 1/2, 0. To double check, you can make sure that that falls on the graph roughly in the middle, and it does. Now this is a formula right here that will be given to you, but you need to know how and when to use it. Same thing for slope up here. You will be given the slope formula, but you need to be able to use that effectively. Our last formula is deriving our distance formula. So we're going to talk about where the distance formula comes from before I give it to you so that you have the choice on how you want to use it. So we've got this triangle graph, x1, y1, x2, y2 between P and Q. So how could we find the distance between those 2 points on a coordinate plane? Now when we see this, you can see that we have a right triangle. And to find the distance of a right triangle, we can use Pythagorean theorem, which is a squared plus b squared equals c squared. Where we have a, b, and c. Now let's see how this relates to our distance formula. Going right here for our A side or our B side. I'm actually going to change the A and the B. It'll make a little bit more sense in a second. So if we look at this A side first, to get from one side to the other going horizontally, that's along our x-axis. So we'd have to take our x2 minus our x1. That would be that distance. And for our B value, finding that vertical distance, we would have to take our y2 minus our y1, trying to find the distance from y2 to y1, just like we would find the distance from x2 to x1 horizontally. So that A value being x2 minus x1, plug that into the A, x2 minus x1 squared. We still have a plus sign from our Pythagorean theorem. And then finding our B value is the difference of the y's, y2 minus y1 squared. And then C value is this distance right here. So that equals our distance squared. Now, what if we wanted to find our distance completely by itself? We want distance to be alone. Now, what is the opposite of squaring something? What is the inverse of squaring something? That is the square root. So you can take the square root of that. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, all under the square root. That gives us our distance between any 2 points. Now I show you this because on example 11, when it asks you the distance between these 2 points, you can absolutely label your points x1, y1, x2, y2, and simply use this formula right here to find the distance. Or if you would rather graph this, count your distance left, right, up, and down, and do Pythagorean theorem instead, that is a valid option. Both ways will be accepted. So to show you what it would look like in the formula, you would have the square root of x2 minus x1, 4 minus negative 2 squared. Again, that minus negative 2 comes a plus y2 minus y1, 14 minus 3 squared. We could plug that directly into your calculator, or we can solve this by hand. Let's solve this by hand, just so we have the practice. 4 plus 2 squared gives us 6 squared. 14 minus 3 gives us 11 squared. So that is the square root of 6 squared is 36, plus 11 squared is 121. Add them together. 36 plus 121 is the square root of 157. Now, if you plug that into your calculator, square root of 157 gives us approximately 12.53. If you have any questions with any of this, please call one of your teachers over to review.